Infosys Corporation is a corporation that provides business consulting, information technology, and outsourcing services. Our company received a small consultation project for a centrifugal pump design of a hygienic product processing plant. Therefore, our team, that led by Aqila with her team members, which is Aisyah, Irfan, and Balqis, are responsible with this project.
The objective of this project is firstly to increase the flow rate by 25%. Secondly, the selection of the pump must also suitable for greater flow rate pumping, which is more than 25% of increase. Thirdly, based on the new flow rate, we have to find the new flow head, the required motor power, the NPSH, and the efficiency of the pump. Note that all the piping, valves, and fittings are not changing.
Before we go to the selection process, a series of calculations has been done to determine the new flow rate, the flow head, the NPSH, and the efficiency as to be taken into consideration. Based on the calculation, the new flow rate that we obtain is 30 meter cube per hour. The required flow head is 39.96 meter and the NPSH is 8.06 meter. So these are the values for finding out the optimal pump by use of diagrams, and these values are going to be used in the selection process. Step 1, the first diagram to be used is the QH diagram, which is the diagram of a TPS 3050. Firstly, the intersection point of flow rate 30 meter cube per hour with flow head 39.96 meters should be made out. The intersection point is located at the area of impeller of 190 mm in diameter. Step 2, the pump efficiency is red and it is approximately 39%. Step 3, the NPSHQ diagram is used and it shows NPSH required is 3 meter. Thus, it can be seen that NPSH required, which is 3 meter, is less than NPSH calculated previously, which is 8.06 meter. This means cavitation will not occur. Step 4, the impeller diameter of 190 mm is required in order to read out the required motor power in the QP diagram. As the flow rate of 30 meter cube per hour, the motor power is 7.5 kilowatt. Fluctuations in volume and pressure must be expected in the plant, as well as the fluctuations of the operating point that causes variation of power consumption of the pump. This is the reason why in principle has increased factor of 5% is fixed. The result is that the motor size should be at least to 10 kilowatt, where the required is 7.5 kilowatt plus increased safety. The next larger size standard motor has 10 kilowatt and should therefore be selected. Step 1. The first diagram to be used is the QH diagram, which is the diagram of a TP3050. First, the intersection point of the flow rate 30 meter cube per hour with flow head 39.9 meters should be made out. The intersection point is located at the area of the impeller of 175 mm in diameter. Step 2. The pump efficiency is red and it is approximately 56%. Step 3. The NPSHQ diagram is used and it shows NPSH required is 1.5 meter. Thus, it can be seen that NPSH required, which is 1.5 meter, is less than NPSH that we considered previously, which is 8.06 meter. This means cavitation will not occur. Step 4. The impeller diameter of 175 mm is required in order to read out the required motor power in the QP diagram. As the flow rate is 30 meter cube per hour, so we get 6 kilowatt for the motor power.
Product specification. In choosing a product, specification is very important aspect that should be concerned. For self-priming pump, model of standard version centrifugal pump type TPS 3050 2-pole 50 Hz. Here is the list of its specification. The pump housing capacity is 316 liter and it made up of stainless steel protection hood and base frame with high adjustable Calute type feed. This pump use 3-phase standard IEC motor with a maximum flow rate of 55 m3 per hour, maximum pump head of 64 meter, maximum housing pressure of 1600 kPa and 190 mm impeller diameter. For non-self-priming pump, model standard version centrifugal pump type TP3050 2-pole 50 Hz. Here is the list of its specification. The pump housing is 316 liter and made up of stainless steel protection hood and base frame with high adjustable Calute type feed. This pump uses a 3-phase 400 volt standard IEC motor with a maximum flow rate of 75 m3 per hour, maximum pump head of 65 meter, maximum housing pressure of 1600 kPa and 175 mm of impeller diameter.
Alright, so we have gone through the selection process of the pump, and in result to that, we choose self-priming pump, which is TPS 3050 with 2-pole and frequency of 50 Hz. This is because self-priming pumps can effectively handle different kinds of fluids, and they are great with corrosive fluids, slurries, and solids. There are also many benefits by using the self-priming pump, which are the installation costs are lower and the runtime is limited. Since the priming system is mostly a non-wetted component, it does not need expensive construction materials and ultimately reduce my construction and equipment expenses. Next, by mixing air and water, a self-priming pump eliminates the need to fill it and the suction piping with water. This will skip the startup procedure for centrifugal pumps and the glitches.
Pump and motor cost. After a few calculation and comparison has been made between non-self-priming and self-priming pumps, all pros and cons can be determined. Based on the table 3, between pump A and pump B, pump A requires a lot more motor power compared to pump B. As a result, the cost for self-priming pump is higher than non-self-priming pump. The price range in between 2,000 ringgit to 3,000 ringgit. Despite pump A having much higher in cost, it has a lot of advantages than pump B and also can be used in a long-term period.